Hi students, welcome to our discussion today. Today's discussion is going to be about the measures of dispersion. So far, we have discussed about the measures of central tendency, where we discussed about the mean, the median, and the mode. These three are actually the measures of central tendency. Remember what I said about the measures of central tendency. The mean, median, and the mode are actually the single values that we normally get from a data that represents the entire data. If, for example, we have got maybe 10 students who have sat for an exam, we can get the class mean for that particular exam. The class mean is going to be a representative for the entire 10 students. Maybe the entire 10 students, the mean is maybe 61%. If we find that the mean is 61%, it does not mean that everybody scored 61, but on average, that was the mean. We can look for the median. The median is actually the median mark, or the mark that is going to be the mid-row, and we say that is now the representative of the 10 students. Maybe now here you are going to find maybe 58 is the median mark, and therefore we can say generally the student scored an average of 58%, but 58% is just the median mark. We have got those who scored above 58%, and we have got those who scored below 58%, but in the mid-row, we have the median. The mode is picking the marks that is most repeated, the mark that actually many students scored. Then we can choose that mark, and then we say that is going to be representative of the entire data. So the mean, median, and mode, it is one value that represents the entire data. So having said that, we went ahead and looked how to calculate the mean, how to calculate the median, and how to calculate the mode. That one was sorted. This discussion now, we want to do what we call the dispersion. We want to calculate the dispersion. One thing that you can agree with me is that if the mean was maybe 62%, it does not mean that everybody scored 62%. But if that is the case, if everybody scored 62%, let us have an example of 5 students and all of them score 62, sorry, 62, 62, 62, 62, and 62. All of them score 62%. What you'll be able to know is this, that the mean will be 62, the median will also be 62, and the mode will be 62. This is a very perfect scenario. The mean, median, and the mode, they are all having the same value. And actually, everybody who sat for that exam scored the same marks. And this is a perfect scenario. In this case, we can simply say there is no dispersion. Dispersion is the same as a deviation. It is the same as a deviation. When all the data is actually similar, there is no dispersion, or actually dispersion is equals to 0. Dispersion is normally calculated as the x minus x bar. Basically, we can talk about it like that, where x are these values we have here. This is x1, this is x2, this is x3, this is x4, this is x5. So if we find our x bar, which is actually mean, is 62, and all the x's are 62, you will find that the deviation is going to be actually 62, which is x1, minus x bar, which is also 62, is 0. When we go to x2 minus x bar is going to be again 62 minus 62, which is 0. So you'll find that deviation, actually there's no deviation from the mean. So when we talk about the dispersion, we want to see how far are the actual values from the mean. Remember, the mean is the same as our x bar. How far is these values from the mean? If we find that all of them are the same as the mean, then the dispersion is 0, and we can simply say that this mean is very, very true, and it is very, very accurate. It talks about the real thing. But more often, it is going to be almost impossible for students to score the same marks. It is going to be almost impossible for all maybe individuals to have the same mass. It is going to be almost impossible for the companies to have the same profit. It is going to be almost impossible for all the companies to sell the same number of items. So as a result of that, we first of all calculate the mean, and then we want to find out how far is this mean from the actual values that were witnessed. How far is this mean from the actual scores if it is an exam? How far is this mean from the actual sales if it is sales, and things like that. So the measure of the difference between the mean and the actual values, which is our x1, x2, and such kind of thing, is actually what we call the measure of dispersion. We want to see how far is this mean true from here. So we can have an example like this. Maybe the students sat for an exam and they score like this. One of them scores 59, the other one 70, the other one 62, the other one 54, and the other one 65. If you calculate the mean here, which is x bar, it will still give you 62. It will still give you 62. But now, note here, these values that we have here, our x1, x2, x3, x4, and x5, all of them are not the same as 62. There is one which is 59, there's another one 72, but there's another one which is similar. We have 54, 65, like that. If we were to calculate maybe the dispersion, the D, you'd find that this one is going to be x minus x bar, which is 59 minus 62. We are going to have 70 minus 62, 62 minus 62, 54 minus 62, and 65 minus 62. You'll find here is going to be negative 3, here is going to be, this one is the same as actually 8, this one is going to be 0, this one is negative 8, this one is 3, like that. But you can be able to see the deviation or the dispersion is not such big. We have a positive 8, we have negative 8. The dispersion is not that big. The dispersion is not that big. So we can simply say that this mean of 62, it is almost talking about the true scenario. It is almost talking about the true scenario because these values, they are not very far from 62. 59, 70, 65, 54, they are not that far from 62. So we can simply say that the dispersion is small. The dispersion is small. And the smaller the dispersion, the true is the data. So this data and this mean is actually true. You can have another scenario whereby you have the marks as maybe there's a student who scored 62, there's another one with 82, there's another one with 62, 42, and 92. If you have a look at this set of data, you can be able to see that the dispersion is going to be very big. And note here, x bar, which is the mean, is still 62. If you compare this mean with these values, there is one value that is 32, which is quite far from 62. There is another one which is 92, which is very far from 62. So we can be able to see here the deviation or the dispersion is big. And actually, if we say that the mean is 62, this mean does not actually give us the true picture about the actual values that we have here. So when we are talking about the measures of dispersion, we want to know whether the mean that we have calculated from the data is actually a true representative. If the mean is the same as all the x values, then it is a perfect scenario, and we normally say that that mean is very, very correct and very true. If you find that the mean and the actual values, the difference between them is very small, then we can say that we can actually be able to derive from that, and we say that the mean is almost talking about the true scenario. But if you have a data like this, the deviation is very big. There's one with 92, there's another one with 32. That difference is so big, and we can say that this mean does not give us a true picture of what is happening. So we can start celebrating that that class did very well, but there is one student who scored very poorly, that 2%. That is actually what I'm referring here. So the measure of dispersion, we want to know whether the mean is talking about the true thing when we compare with the actual data. So we have got different methods of calculating the dispersion. They include, we have got a method called range, we have got the standard deviation, we have got the variance, and we have got the absolute mean deviation. We have got also the quartiles, we have got the percentiles, and the deciles. All these are used to calculate the dispersion. The easiest of them is actually the range. The range is actually the difference between the highest value and the lowest value. Like in this case, our range will be 92, which is the highest value, minus the smallest value, which is 32. So range here is normally given by the highest minus the lowest value. That is actually how we do it. And the smaller the range, the correct is the data. If you find that maybe the range is maybe like what we have here, like what we have here, the range is going to be 70 minus 54. The range here will be 20. Uh, Actually, it's going to be 16. The range is going to be 16, which is not that big. If we have another example here where we have got all the data being the same, the range is 0. So the smaller the range, the better is the data, or the correct is the mean. So the range is normally calculated by that. In our subsequent class, we are going to see how do we calculate these measures of dispersion. Thank you very much.